Hello everyone. In this video, we will start rapid revision notes of nuclear chemistry. So, firstly, we will discuss about fundamental particles. We have two types of fundamental particles. The first one is leptons and second one is quarks. So, we have two types of fundamental particles. The first one is leptons and second one is quarks. We have various leptons like electrons, muon, tau, electron neutrino, muon neutrino, tau neutrino. Similarly, we have different types of quarks. The first one is up, second one is down, next one is charm, next strange, and top and bottom. Next topic is composite particles. Composite particles are those particles which are made up of quarks. So we have two types of composite particles. The first one is mesons and second one is baryons. Mesons are made up of two quarks. Means when two quarks combine, they form mesons. And when three quarks combines, it forms baryons. We have example of mesons p ion and k ion, etc. Similarly, we have some examples for baryons like proton, neutron, etc. Proton is made up of three quarks, two up quarks and one down quarks. Similarly, neutron is made up of two down quarks and one up quarks. Only electron is fundamental particles. Proton and neutron is not a fundamental particles. Next, bosons. Bosons are those particles which are made up of even number of quarks. Next one is fermions. Fermions are those particles which are made up of odd number of particles. Made up of odd number of quarks. Next, we will discuss about isotopes, isobars. What is isotopes? Isotopes are those compounds which have same number of electrons and same number of protons but different numbers of neutrons. We have different number of neutrons means mass number of both A and B will be different. Mass number, how we will calculate mass number? Proton plus neutron. So proton plus neutron of A does not equals to proton plus neutron of B. Means same number of electron proton but different number of mass. Similarly, isobars. Isobars have same different numbers of electron and protons. Neutron is also not same in both compound, but mass number proton plus neutron is same for both A and B. Next is isodiaphers. In case of isodiaphers, number of electron in both A and B are different. Same proton is also different. Neutron is also different. But neutron minus proton is same in both A and B. Next is isotones. In isotones, number of electrons in A and B are different. Similarly, proton is also different, but neutrons are same. Number of neutrons in A and B is same. But mass number means proton plus neutron in A and B is different. Next, we will discuss about mirror nuclei. Mirror nuclei are those compounds which have same pairs of isobar. Mirror nuclei is also called as pairs of isobar. In isobars, we have different number of protons and electrons and neutrons, same mass number. In case of mirror nuclei, electron proton is different, but they differ by one only. Means protons and neutrons differ by one only. For example, helium 1, 3 and 2 and helium 1, 2 and 3. Here 3 is mass number, 1 is proton and 2 is neutron. One more example, 13 C7 6, mirror nuclei of 13 and 7 6. Here carbon 6 and nitrogen 7 are mirror nuclei. Next, we will discuss about the classification of different types of nuclei. First one is stable nuclei. Total we in nature we have 274 stable nuclei. In case of stable nuclei, protons and neutrons remain same, means unchanged. For example, 12 C6 and 14 and 7. But nucleons can change by the radiation which have energy greater or equals to 10 mega electron volt. Second types of nuclei are unstable nuclei. Total 2000 man-made nuclei are there which are unstable. They spontaneously changes with time. For example, bismuth. Next we will discuss about the stability of nucleus depends on which factor? Nuclei stability influenced by various factors, which first one is mass defect, represented by delta M. We have formula for mass defect, that is Z into mass of proton plus A minus Z into mass of neutron minus M. Here Z is atomic number, or we can say number of protons, and A is mass number. So this is predicted mass and capital M is the actual mass. By subtracting both, we will get the mass defect. So mass of proton is generally 1.00815 AMU and mass of neutron is 1.00699 AMU. If mass defect will increase, stability of nuclei will also increase. The second factor is binding energy. For binding energy, we also have one formula, that is delta M equals to 931 mega electron volt. Here delta M is nothing but mass defect. We have one formula for binding energy per nucleon, that is binding energy divided by number of neutron plus number of protons. When binding energy per nucleon increases, stability also increases. If we get value in electron volt, so we can convert it into joule. If we have 1 electron volt, means 1.6 into 10 to the power minus 19 joules. And 1 mega electron volt equals to 1.6 into 10 to the power minus 13 joule. Then the third factor is neutron by proton ratio. For stable nuclei, neutron by proton ratio is equals to 1 up to Z equals to 20. Next, we will discuss about Segre's plot. We draw Segre's plot for heaviest stable nuclei. For example, bismuth, which has 83 protons, 209 is mass number, and 126 neutrons. Here, neutron by proton ratio is 1.51. In heavy nuclei, proton and neutrons increases. If proton and neutron both increases, but number of neutrons increases more. Number of neutrons increases more than proton. In that case, size of nucleus also increases. If size of nucleus will increase, then Coulombic repulsion between proton decreases. Neutron by proton ratio increases. In that case, this is condition of radioactive decay. We can draw Segre's plot. So, in y-axis we have number of neutrons and in x-axis we have number of protons. Normally, if for stable nuclei, neutron by proton ratio is 1, so we'll get straight line. This stability plot only follow up to Z equals to 20. Above Z equals to 20 means atomic number greater than 20. The stability belt comes between 1.56. This is called belt of stability. What is belt of stability? Belt of stability is graph of stable element on basis of neutron by proton ratio. We have two cases. If neutron by proton ratio lies above stability belt, in that case beta emission is occurring, which reduces the neutron by proton ratio. How it reduces neutron by proton ratio? By converting neutrons into protons. For example, if we have one neutron which converted into proton and one electron neutrino comes out, one is anti-neutrino. Case of anti-neutrino, balance spin nucleus, state and energy. Second case is if neutron by proton ratio lies below stability belt. In second case, we also have two possibilities. First one is positron emission, means emission of positive electron. When neutron by proton ratio increases, positron emission occurring. Like one proton we have, which converted into one neutron and produce one positive electron plus V0. This reaction occurring when energy is greater than 1.02 mega electron volt. Second possibility is orbital or K electron capture. For example, 1p1 we have plus 1 electrons captured and it form 1 neutron plus antineutrino plus X-ray released. This reaction occurring when energy is less than 1.02 mega electron volt. Here this is negative electron is K cell electron. Because of this electron capture, one vacancy filled by electrons jumping from higher cells. Because electron jumps from higher cell to lower cell, due to this X-ray produces. That's why in reaction also we have written X-ray on the product side. X-ray produced because of the electron jumping from higher cell to lower cell. So this is all for this video. Next we will continue this topic in next video. So for now, if you have any doubt, you can comment on the comment section. So thank you for watching this video.